Good evening, everyone. So, welcome to my YouTube channel, Maths Sapro. So, today we are going to see sixth lecture on infinite series. We will study in integral test. This is very important test to check convergency of a series. Okay, projective series. So, integral test. So, before integral test, I would like to write a remark. Okay. Convergent integrals of the form a to infinity fx dx. We say that the integral a to infinity fx dx is convergent if limit epsilon tending to infinity a to epsilon fx dx exists. Okay. In other words, there exists unique L belongs to R such that limit epsilon tending to infinity a to epsilon fx dx is equal to L. Then we say that that the integral a to infinity fx dx is convergent. Okay. So what is integral test? Integral test. Okay. So is convergent if a to infinity if a to infinity fx dx is not convergent, then we say that the integral a to infinity fx dx is divergent. Okay. So we will see now integral test. What is integral test? Integral test. Let summation n goes to 1 to infinity be a series with non-negative terms. Non-negative terms means it means an is greater than equal to 0 for all n belongs to n. Suppose that an is equal to fn for all n belongs to n, where f is continuous, non-negative and monotonically decreasing function defined on 1 to close interval 1 to infinity open, then summation n goes to 1 to infinity an and summation and integral 1 to infinity fx dx both converge or diverge together. Converge or diverge together. Okay. So let's see its proof. How it will be proved? It is simple. Proof. Suppose I have this one. This is x-axis, this is y-axis, and this is my function, monotonically decreasing function, non-negative function. So this is my a1 term and this is my a2 term, like that. This is a3 and so on. This will be an term and this will be finally an plus 1 term. Okay. So this I will complete, this I will complete. Okay. And this I will complete. Okay. Okay. So let's say these heights are a1 and this height is a2 and this height is a3 and this height is an. Okay. These are the a1, this is a2, this is a3, like that. This is an, this is. So what is the area? So if I will take, so what will be this? So you see that this integral. So this integral, if I am taking 1 to n plus 1 fx dx, so that is less than a1 times. You see because the integral 1 to n plus 1 denotes this area, this point to n plus 1, the area bounded by the curve and interval 1 to n plus 1, that is less than, what is the UPF in this interval 1 to n, 1 to 2, you see that this is less than a2 plus a3, like that, up to an. You see that this is greater value. Okay. Because we are taking this area and then we are adding this area. and that is always greater than this, the area bounded by this curve and this n to n plus 1 interval. Okay. So this is equation number 1. Again, if we take these smaller intervals, this interval, this, it means we are approximating this area by lower rectangles. Then tell me, what is A2 plus A3 plus AN? What is? Then A2 plus A3 up to AN is less than summation 1 to n fx dx. Let's see, this is equation number 2. Okay. Okay. So this is this. I can add this both the sides by A1. I can add both the sides A1. So this implies A1 I can add, that is A2 plus A3 up to AN. This is less than A1 plus 1 to n fx dx. Okay. So from 1 and 2, what we have? So from 1 and 2, from 1 and 2, we get, what we get? We have this one, this integral n to 1 fx dx is less than A1 plus A2 plus AN. And from equation number 2, we have this one. Okay. Now, what is this? What is this? This is Sn, partial sum of the series. And that is A1 plus. Okay. So this is dx. Now, so this is my equation 3. Okay. Now, first assume that the integral 1 to infinity fx is divergent. Then what will happen? Then 1 to n fx dx tends to infinity, and 1 to n plus 1 fx dx also tends to infinity as n tending to infinity. Okay. So this inequality, third inequality, is true for all n belongs to n. This is true for n belongs to n. Okay. Now this integral is divergent. We have assumed that the limit will not exist. It will be infinity. Because if limit is finite, that will be convergent. We have assumed that integral divergent, so this will be divergent. Now from 3, we have from 3 we have 1 n plus 1 fx dx, that is less than Sn, and that is a1 plus 1 to n fx dx. Now letting n tending to infinity, we get, because this part is going to infinity, this part is going to infinity, and so after adding it will also cancel. So this will imply that this will tends to infinity. Okay, this will tends to infinity. So therefore, what we get, I'm writing in new line. So letting, so this implies, because if lower thing is tending to infinity, upper thing is tending to infinity, middle thing will also tending to infinity. So this implies Sn tending to infinity as n tending to infinity. So this implies the series Sn, the series An is divergent, also divergent. Okay. Conversely, assume that this integral, conversely assume that this series An is divergent. So this implies Sn will tends to infinity, because all the terms of the given series, because all the terms of the given series are non-negative. It means the series cannot diverge to minus infinity. It will diverge to plus infinity. Okay. Or it cannot be oscillate also. So it will, because for terms are non-negative, so it will tending to infinity. Okay. Again by third, again by third, we have, but using the this part only, using this part only, we have Sn is less than this. I'm using this part of third only. So this implies Sn. Okay. Now letting n tending to infinity. So letting n tending to infinity, we get, because when n tending to infinity, Sn, this part will tends to infinity. Okay, this part will tends to infinity, and this is upper thing, non-negative integral, that is also will tends to infinity. We will get, so we get this integral 1 to infinity, 1 to n fx dx tends to infinity. So this implies as n tends to infinity. So this implies the given integral 1 to infinity fx dx is divergent. So we have shown that the integral and integral, both the integral diverge together. So that also means we have shown that integral 1 to infinity fx dx is divergent if and only if this series is divergent. That also means the meaning is same. Saying divergent is also saying this integral is convergent if and only if this series an is convergent. So what is the meaning of this? This means this integral, hence 1 to n fx dx and summation n goes to 1 to infinity an both converge or diverge together. Diverge together. Okay. So theorem is proved. Now we do some examples. Example number 1. By integral test, so that the series, the auxiliary series summation n goes to 1 to infinity 1 upon n to the power p. Okay. Converge if p greater than 1 and diverge if p less than equal to 1. Okay. P less than equal to 1. Okay. So let's see solution. So case first, my P is in this range. Okay. P is in this range. P is in the same, then define fx is equal to 1 upon x to the power. This is continuous, non-negative, monotonically decreasing function. Okay. And you also observe one thing, and an is nothing but n to the power p, that is nothing but fn, for all n belongs to n. Okay. Now what is this integral? 1 to 1 to epsilon fx what is this integral? What is this integral? So 1 upon fx dx. What is this integral? This is 1 to epsilon 1 upon n to the power p dx. What is its integral? Its integral is nothing but minus p plus 1 minus p plus 1 to epsilon. So what is this? This is epsilon minus p plus upon minus p plus 1, and that is okay. That is plus 1 upon minus p plus 1. Okay. Okay. So I have taken this and defined this, and that is continuous non-negative monotonically decreasing function. Okay. So I have taken this. So I am taking here case 1. If p is not equal to 1 for the timing, then I have this one. Okay. I have this one. So integral is minus p plus 1 upon minus p plus 1. Okay. So letting so this is an equal to 1 upon n to the power p, and its integral is 1 to its integral is this is x to the power p. This is x to the power p. This is x to the power minus p plus 1 minus p plus 1. Okay. Okay. So now so this is equal to this, and p is not equal to 1, and p is in this range. P is in this range. Okay. Then we have this one. So letting epsilon tending to infinity, we get epsilon tending to infinity. So what will be this actually? What is here? Here is minus. Here is minus. So letting we get this integral 1 to epsilon limit epsilon tending to infinity. We get fx dx is nothing but 1 upon 1 minus p. Okay. Sorry, p minus 1. P minus 1. Okay. Okay. So p minus 1 we have this one. For what? P, so we are taking this range actually. So we are taking this range. So we are taking this range. So you can say part A. I'm taking P in this range. P, I'm taking P in this range. Okay. Okay. So I'm taking P in this range. So first case is P in this range. And I am taking in part 1. We have this one. So this tends to this range. So it means actually we are taking this one. We are taking this case. P greater than 1. Then we have this one. So we have shown that this is convergent. So this implies if P greater than 1, then this integral 1 to infinity fx dx is convergent. So this implies by integral test this series n goes to 1 to infinity, 1 to the power np is convergent if p greater than 1. Okay. Now, B part I am taking this one. B part I am taking. If P is equal to 1, then what is this? This is P is equal to 1. Then what is this? This is 1 upon x dx. That is log x a to epsilon. That is log epsilon minus log a. Okay. Now limit. So what is the limit? So what is the limit? Limit epsilon tending to infinity. This integral fx dx is equal to infinity. So this implies for p is equal to 1, the integral 1 to infinity fx dx is divergent, is divergent, is divergent by integral test. This summation n goes to 1 to infinity 1 upon n is divergent because p is 1. Okay. Now we are taking c. If my p is in this thing, then what is this? This is a to epsilon fx dx. What is this? This is nothing but x to the power 1 minus p, 1 minus p. Okay, 1 minus p. So actually here this is 1. This is 1. This is 1. This is actually log epsilon. And this is 1. Okay. So it is 1. Okay. So what is this? Epsilon to the power 1 minus p upon 1 minus p. And this is minus 1 upon 1 minus p. Okay. So letting epsilon tending to infinity, because 1 upon as p is in this range implies 1 minus p is greater than 0. Now epsilon tending to infinity, we get what is the limit of this? Limit is limit epsilon tending to infinity 1 to epsilon fx dx is infinity. It means limit does not exist, so this implies for p in this range we get this integral 1 to infinity fx dx is divergent So this implies summation n goes to 1 to infinity 1 upon n to the power is divergent for by integral test. Okay. So, so next, case 2, case second. You see case second, what is this? P is less than 0. Then n goes to 1 to infinity 1 to the power n upon p. So what is 1 upon n to the power p? Nth term, that is 1 minus p. Where p is greater than 0. 1 minus p is greater than 0. So this will tends to infinity as n tending to n. So this implies an does not tends to 0 as n tending to. So it means convergent series nth term always tends to 0. If does not tend to, what it means? It means this series an is divergent. Or hence combining case 1 and case 2, we conclude that summation n goes to 1 to n. This series is convergent if p greater than 1 and divergent if p less than equal to 1. So this is proved. Okay. Now see this function. Example 2. Example 2. Is the following series convergent? Convergent. What is the series? N upon into this series. Okay. The solution. So fx is equal to x e to the power minus x square we say. So what is f0? F0 is 0. Okay. Sorry, f1. So what is? Take this function. Then f1 is equal to 1 upon e, that is greater than 0. Okay. Okay. Now what is f dash x? What is f dash x? It is e minus x square plus x e to the power minus x square minus 2x. Okay. So it is e to the power minus x square and this is 1 minus 2x. Okay. So this is less than 0 for all x greater than 1. Okay. So this implies f is monotonically decreasing. Okay. Now this is monotonically decreasing. Now f is monotonically decreasing, so f1 will be f is monotonically decreasing. Sorry, I should write one thing here. So f is monotonically decreasing, and you know that here in place of calculating this, you know that what is the limit of this function extending to infinity. So what is the limit of this function extending to infinity fx? What is this? This is limit extending to infinity x upon e x square. So it will be by L. This is infinity upon infinity form, indeterminate form. Okay. Now use L orbital rule. So this will be limit extending to infinity 1 upon 2x e to the power x square, and that will be infinity by L or orbital rule. Okay. So this is actually 0. This is limit is 0. So this is limit 0. Okay. Now f is since now f is monotonically decreasing on, and therefore we get we get we get limit x tending to infinity fx will be less than fx for all x belonging to 1 to infinity, because it is monotonically infinity. If I will tell x tending to infinity, so it is decreasing. So what is this? This is okay. Now see that from here what we have, f is non-negative. So this implies, so f is, what is the meaning of the f is non-negative on this. Also observe that fx is equal to x into e to the power x square is continuous on this interval. So what we have? Finally we have f is continuous, f is f is fx is equal to x e minus x square is continuous non-negative monotonically decreasing function on 120. So we conclude that, okay. Also observe that an is equal to, what is this? N e minus n square. That is nothing but fn for all n belongs to n. Okay. So now calculate integral. So what is this? Next, what is this integral? 1 to epsilon fx. Yes, what is this? This is 1 to epsilon x e to the power minus x square dx. Okay. So what will be its integral? After calculating its integral, you will find that its integral is nothing but minus x square by 2. Its integral is this. You can calculate its integral. It is easy to calculate. So this is e by e minus upon 2. It will be, okay, and this will be e minus epsilon square by 2. Okay. So now letting, okay, so letting epsilon tending to infinity, we get, because e to the power, this is a, epsilon is a positive number because we are taking epsilon greater than 1. So squaring, it will make positive, no problem. So if you take, so we get epsilon tending to infinity, and this will imply, what will be this integral? This integral 1 to epsilon limit epsilon tending to infinity. This is nothing but, so this is e to the power minus 1 upon 2, and that will be 0. Okay. So this implies integral is convergent. So this implies, this integral 1 to infinity fx dx is convergent by integral test the series summation and goes to 1 to infinity, and e to the power minus n square is convergent. Okay, so this is done. So this is done by integral test. Now example 3. Example 3 is the following series convergent. What is the series summation n goes to 1 to infinity 1 upon 2 to the power log n. Okay. Solution. You see this function fx is equal to 1 upon 2 log x. So this is continuous, non-negative, negative. You can check it, non-negative, and monotonically decreasing function on 1 to infinity open it. Now, or and an is equal to 1 upon 2 to the power log n is equal to fn for all n belongs to n. Okay. Now, what is the 1 upon epsilon fx dx value? It is 1 upon epsilon 1 upon 2 to the power log x dx. If put log x is equal to y, it will imply put log this in x is equal to e to the power y. So then it will imply dx is equal to e to the power y dx. Okay. Then the integral, so this will imply what will be the change of integral. So this implies 1 fx dx is equal to. So what will the limit? When you put 1, it will be 0, limit will be 0, and it will be log epsilon, and it will be 2y, okay, e to the power y dy. Okay. So what is this? Due to log epsilon, it is e by 2. Okay, so what is the its integral? Okay, what is its integral? Its integral is, how to calculate its integral? What is the integral of a to the power x? Okay, a to the power e to the power 2 upon y upon log e by 2. Okay, so this is integration. Okay, 0 to log epsilon. Okay, now, so what is this? This is 1 upon log e by 2 will be, what will be this log e by 2 will be? Value, what will be this value? Log e by 2. And what is this? E by 2 log epsilon minus, it is 1. Now, Since e by 2 is greater than 1, because e is 21718 something, its value is. So letting epsilon tending to infinity, we get log epsilon tending to infinity. So this will imply limit epsilon tending to infinity 1 to this integral is in limit. This implies the integral is this integral one to infinity fx dx is divergent, hence by integral test the given series summation n goes to 1 to infinity 1 upon 2 to the power log n is divergent. Okay, so it is done. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you on next.